These notes are on calculating surface area of rectangular prisms. Recall from our earlier lessons that a rectangular prism consists of 6 faces. So before we start, let's actually go and review what surface area actually is. So we're going to write our definition on our notes page. Surface area is the area, and remember area is calculated in square units. So it's the area of all faces of a three-dimensional figure. In this case, we're going to be using a rectangular prism. So in this picture, we have a rectangular prism, and what I've done is I've labeled the 3 dimensions that make it a three-dimensional figure. 4 centimeters is the length, 2 centimeters is the width, and 6 centimeters is the height. So now that all of those are labeled, we are going to calculate surface area of this figure. So here's our problem that we're doing today. Karen bought the same gift for all of her siblings. She put their gifts in a gift box that looks like the box shown here. Help her figure out how much wrapping paper it would take to wrap the box. Wrapping a present is calculating surface area because our job is to cover every single surface. So if you look what I've done, I've picked a color to represent each surface or each face, and I've completely covered it. The reason why I've picked different colors for these is because they're different sizes. This purple represents the front, this blue represents the top, and this orange represents the left side. In order to calculate the entire surface area of this, I need to know the area of each face individually. So first, we're going to look at the front. So what I've done is I've sketched just what the front looks like. It has 4 centimeters as your length and 2 centimeters as the width. And it's in the shape of a rectangle. So I'm going to find the area of just the front. And the way we do area of a rectangle is multiplying length times width. That's the formula that we need to use. So then I plugged in 4 for length, 2 for width, and found that the front has an area of 8 centimeters squared. Again, area needs square units. So area for the front is 8 centimeters squared. Now the good thing about a rectangular prism is that the front and the back are exactly the same size. So whatever work I've done for the front, I should be able to say the exact same thing for the back. It looks exactly the same, it has the same dimensions, and it also is going to have the same area. So between the front and the back, I have 8 centimeters squared and 8 centimeters squared, but that's not the whole figure yet. I still have 4 more faces to calculate. So the next one we're going to look at is the top of the shape, which I've sketched here. If I look at the top of the shape, I see that I have 4 centimeters here, 6 centimeters here. My formula changes a little bit because I no longer have length and width, I'm now having length and height. So if I look at the picture as a whole, I have my length here, 4 is parallel here to 4, and I have 6 here as my height. So to find area, I calculate 4 times 6, that's 24 centimeters squared. Again, area is square units. So the length and the height make up the top. The length and the height also make up the bottom. So whatever I've done for the top, I should be able to do the same thing for the bottom because those two faces are congruent or equal. They're the same size. So I have 4 faces calculated now. Front, back, top, bottom. So the only faces left are the left face and the right face. So I need to sketch the left face to calculate the area. When I do that, I see that now I've got 6 and 2 as my dimensions. So we look at the figure as a whole, 2 centimeters was over here, and it's parallel to this left side, so I know this dimension 2 is still in the figure. And the other side is parallel with the 6, so I need 6 as my other dimension. So this time my formula is width times height, because those are the two dimensions that I'm using. Substitute 2 for width, 6 for height, and the area of the left side is 12 centimeters squared. Just like the other faces we did, the left side has a congruent side, and that side is the right. So when I reveal the right side, it should be exactly the same as the left, which means they've got the same area, 12 centimeters squared. Now that I have all 6 faces, I go back to my definition. The area is all faces of a three-dimensional figure. That's surface area. So I need to take each individual face and do something with them. So let's look at our questions at the bottom. It says, looking at your table, which we've just created here, what do you notice about the relationship between front and back, left and right, top and bottom? So we've been discussing this throughout this worksheet. The front and back are congruent. The left and right are congruent, and the top and bottom are congruent. So what does that mean? It means that they are the same size, which in turn means they have equal areas. Which works out for us because I'm really only finding 1, 2, 3 areas. If I find the front, I know the back. If I find the top, I know the bottom. And if I find the left, I know the right. So question 2 says, using the relationship you discovered, do you think there's a shortcut to finding the surface area, which is the amount of area it takes to wrap up that box? Well, there is a shortcut. I could go through and add 8 plus 8 plus 24 plus 24 plus 12 plus 12. Or I could notice that I have 2 8s plus 2 24s plus 2 12s. Remember that parentheses mean multiplication. So instead of adding each of these individually, I can use multiplication. 2 times 8 is 16. 2 times 24 is 48. And 2 times 12 is 24. Again, that's not my final surface area. I still am going to have to add because I want to cover every single surface. So now to finish out my problem, I need to add 16, 48, and 24 to get my final surface area. So when I add those together, I get 88 centimeters squared. That is my surface area. Now that you've finished watching this video on notes, I want you to go to the practice and I want you to label these problems so that when we check them, we know that we're getting the right answer. So this is going to be problem 1, 2, 3, 4, 5, 6, 7, and 8. Remember we're finding the surface area, which means I'm not finding just one area. I need to find 6 different areas because there's 6 faces. So in each of these 8 problems, I need you to calculate the surface area of these figures. Basically, how much wrapping paper would it take to cover this? That's what surface area really means. So at this time, you're going to stop the video and work on these problems on surface area.